Hello students, how are you? Hope you're doing well and you're studying, having fun. What do you think we are going to study today? What can you see on your screen? Yes, you're right. We are going to study coagulation of blood, and which is also known as hemostasis, right? So this is the process, and very simply that's showing very beautiful animation. And this is what we are going to study today in a lot of detail, right? So we'll be doing it in a step-by-step process, each process one time, right? One at a time. So what are we going to do today? The topic is in body fluids and circulation. We are going to do coagulation of blood, right? And this is what we are going to do this, and it has a very specific term, and this term is hemostasis, right? Hemostasis. Hemo means blood, status means stop. What is hemostasis? It is a sequence of responses that stops bleeding. So basically today we are going to study these sequence of responses that stops bleeding. Okay, so before we start that, the first thing that we need to see is why the blood is not coagulating on its own. Why is it thin? So the first thing that we are going to study is how blood is naturally thin. Why it is not coagulating on its own, right? Why is it just in a flowing state? So we'll be doing 3 ways in which the blood is not getting coagulated on its own. So suppose these are your endothelial cells. Okay, and here also your endothelial cells. And some collagen. And some collagen. And below it some smooth muscle. What is this? These are smooth muscles. So you know now what are we talking about? These are endothelial cells, right? And this is collagen. And these are smooth muscles, right? And blood is flowing in it. Why is it flowing? We are going to see that. Why is it naturally thin? So these endothelial cells secrete 2 things, right? So first of all, they secrete this nitric oxide and also PGI2 or prostacyclin. It was also known as PGI2. And what are these 2 things doing? There are some platelets roaming around in the blood. What are these? These are platelets. And these platelets are sleeping, or they are inactivated platelets, right? So we can just say they are sleeping, snoring nicely. What happens when this nitric oxide and prostacyclin, why are they sleeping or why are they inactivated? Because this nitric oxide and prostacyclin is preventing these both things, is preventing the platelets from clotting. So what is nitric oxide and prostacyclin doing? It prevents clotting by doing what? By inactivating the platelets. So this is the first way by which the blood is kept naturally thin. So let us write a little. The first thing that we saw was that the endothelial cells do what? They secrete they secrete nitric oxide and PGI2 or prostacyclin. They're naturally found in the blood. And what do? They inactivate the platelets, and thereby they do what? They prevent clotting, right? So the first way why the blood is naturally thin, we have done. Endothelial cells secrete nitric oxide and prostacyclin, which thereby inactivate the platelets and which thereby prevents clotting. Now let us see the second mechanism by which the blood is kept naturally thin. So the second step is that there is this protein or proteoglycan, heparin sulfate. Heparin sulfate. What is heparin sulfate? It is a natural anticoagulant. And it binds with what? It binds with anti-thrombin 3, right? It binds with anti-thrombin 3, and which thereby inactivates the platelet and thereby prevents clotting, right? Inactivates platelets and thereby it prevents clotting. So let us see what is happening in the second way. The second way, the endothelial cells have this heparin sulfate. That's a protein or a proteoglycan. And what is this heparin sulfate? It is a natural anticoagulant that's present in the blood, right? And it binds with what? So what is it happening? It binds with anti-thrombin 3. You read again and again and you don't need to learn. These terms will come naturally to you if you just see the video and make notes 2-3 times, right? And what are they doing? It is basically what is doing, it is degrading the clotting factors to 9 and 10. When we'll do clotting, you will see about these factors. So there are basically some clotting factors in the blood that helps in the clotting, right? So there are these clotting factors. So what is basically this doing? Heparin sulfate, it is binding with 83 and it is inactivating these. So finally, what is happening when it is degrading the clotting factors? The blood cannot clot, right? So we have seen the second mechanism. Basically, instead of writing inactivates platelets, what we can do? We can write that it is degrading a better way to write, it is degrading clotting factors. And which all clotting factors? 2, 9, and 10. Right? So it is degrading clotting factors, and what will happen? So the blood cannot clot. The blood cannot clot, right? Now we'll see one more thing, and then I told you before that we'll be doing 3 ways to see how the blood is kept naturally thin. Now let us see the third thing. Now there is this protein on the endothelial cell. Draw with me or else you lose what I am saying. Right? There is this protein on this endothelial cell, and this is thrombomodulin, and it binds with a factor, that's thrombin or factor 2, right? So basically this is thrombomodulin and this is thrombin. So basically you can imagine that there is a protein that's called a protein C in the blood. Suppose this is the protein. Let me make it with a different color. Suppose this is a protein. When it passes from here, what happens? It is in the inactive state. When it passes from here, this thrombomodulin plus thrombin makes it, this becomes what? This becomes its active state. And in the active state, what does it do? It degrades clotting factors. Now let us see. what is this third mechanism? So what happens? What happens? There is this protein. There is this protein. What is the name of the protein? Thrombomodulin. And what does it do? It binds with what? It binds with thrombin, or thrombin is also known as factor 2, right? It binds with it, and basically what does it do? There is this protein C in the blood, right? And it is what? It is in the inactive state. When thrombomodulin and thrombin binds and this protein happens to flow there, what happens? It becomes into this protein C, which is what? Which is in the active state now. And in the active state, what will it do? It will degrade. It will degrade clotting factors. It will degrade clotting factors 5 and 8. We'll do all these clotting factors when we are doing coagulation of blood, right? So basically what is happening? 3 ways. The first way is what? How the blood is kept naturally thin. The endothelial cell is secreting nitric oxide and prostacyclin, which when combined, they inactivate the platelets. And then there is this proteoglycan heparin sulfate. It binds with antithrombin, or 83, it degrades clotting factors. And similarly, thrombomodulin binds with thrombin and it activates the protein C, which does what? Which degrades the clotting factors, right? So you can just draw this, or you can take a screenshot or whatever of this. And this is what this diagram is telling you, how the blood is kept naturally thin, right? So I think this much is clear to you, that how the blood is kept naturally thin. Now let us come to the part where we will study about how this hemostasis is taking place, or now we'll come to the sequence of responses that stops bleeding, right? So these are the 3 things that we did: thrombomodulin binding with thrombin, and thrombin is also known as factor 2. It is very important. This factor 2 or thrombin is very important. In many chapters, you will not see this, how the blood is kept naturally thin, but I thought I should tell you. It's very interesting. So I just, before coming to coagulation. So now we'll do the 5 steps of hemostasis, right? 5 steps of hemostasis. So what are these 5 steps of coagulation? First is vascular spasm, right? Second is platelet plug formation. The third is coagulation. That's the most important step. The fourth is clot, retraction and repair. Remember these steps, they are very, very important. And the fifth one is fibrinolysis. So let us start with the first step, that is vascular spasm. So let us learn those 5 steps: vascular spasm, platelet plug formation, coagulation, clot retraction and repair, and fibrinolysis. So let us do the first step, that is vascular spasm. Right, vascular spasm. Right, so the first step is, so basically vascular spasm is like the contraction to reduce the bleeding. Contraction of what? Contraction of the endothelial cells. So now let us see how vascular spasm is taking place. Right, so now as we drew, these are the endothelial cells, and suppose there is this injured endothelial cells, and that's why what will happen? The blood will gush out. So the blood is flowing here, the blood is flowing here. Now there's an injury, the blood will flow out. We have to stop it. How can we stop it? If there is a vascular spasm, means the endothelial cells contract and come close. So this If they'll come close, what will happen? It will stop bleeding. So now let us see what all is happening. So for this vascular spasm, these are the endothelial cells. This is the injured site where we have to stop the bleeding, right? So basically, and then there is this collagen, right? There is this collagen, and then there is this smooth muscle. There is this smooth muscle, and in the smooth muscles, there are these pain receptors, right? There are these pain receptors, nosioreceptors if you want to know, and there are other receptors also on this smooth muscle. So we'll just draw these other receptors also. So let us see how this is happening. So basically what happens, these endothelial cells secrete an endothelin. This is secreting what? This is secreting an endothelin. And what is this endothelin doing? This is going and binding with this receptor on the, this is what? This is endothelin, right? You are with me? These are endothelial cells, as we already know. This is the collagen. This is the smooth muscle. And this is a receptor on the smooth muscle. And this is a pain receptor. Okay, we'll see about this also. So what happens is endothelin comes and binds with this receptor on the smooth muscles. And what does it do? When it binds, it causes contraction. It causes contraction, and or we can say vasoconstriction. And if there's a vasoconstriction, if the endothelial cells are coming close, what will happen? The bleeding will reduce or stop, right? So now the first step we saw what was, how is the vascular spasm taking place? The endothelial cells, very easy to remember, endothelial cells secrete endothelin. And what does this endothelin do? This endothelin comes and binds with what? It binds with the receptor on the smooth muscle. And what happens when it binds with the receptor on the smooth muscle? It causes vasoconstriction. So the first way how the vascular spasm is taking place, we know. Now let us see the second way how this vascular spasm is taking place. So this is the endothelial cell. And now what happens, the second mechanism is known as myogenic mechanism, when there is a direct injury to the smooth muscle. So the injury is so much that this smooth muscle has got hurt. What will happen then? So what will happen when the smooth muscle has been hurt? So what will happen that, let us write, the second way is myogenic mechanism. And what is this myogenic mechanism? Myo, whenever there's a word myo, what do we do? Muscle. So the smooth muscle is injured, is directly injured. Now when the smooth muscle is directly injured, what will happen? The smooth muscle will try to contract, and this will cause vascular spasm and the bleeding will reduce. Now let us see the third mechanism, and that is what? That is the pain receptor. Remember, we drew the pain receptor activation. So what is this pain receptor activation? Let us see the third mechanism, pain receptor. Now इसमें क्या हुआ था? myogenic में smooth muscle injure हो गई थी. Pain receptor activation में क्या होगा? Direct, very logical, direct injury to pain receptors. Now let us see what will happen when there is a direct injury to pain receptor. These are the pain receptors that we drew. Now whenever there is this injury, what will happen? These pain receptors that I have drawn here, they will these pain receptors, they will secrete some inflammatory chemicals like histamines and all. So what are these? These are some These are some inflammatory chemicals. Okay. And what will these inflammatory chemicals do? These inflammatory chemicals will stimulate the pain receptors, and these pain receptors will cause what? They will cause vasoconstriction. So what happened? There was a direct injury to these pain receptors. There was a direct injury. I'm just drawing some way so that you may remember. And when there was a direct injury, what happened? There were these chemicals released. And what were these chemicals? These chemicals are inflammatory chemicals like histamines. And what will happen? They will stimulate what? They will stimulate the pain receptor, and there will be a vasoconstriction. Now let us write. So this is the first way in which endothelin was secreted. There was this myogenic mechanism, the second way, and the third way is pain receptor activation. So actually what is happening there, the pain receptor, when there's an injury, pain receptor is injured, what will happen? Or there is a direct contact to the pain receptor, it will secrete what? It will secrete some inflammatory chemicals. It will secrete some inflammatory chemicals, and these inflammatory chemicals will do what? They will stimulate these pain receptors, and these pain receptors will thereby cause what? Pain, and thereby cause vasoconstriction, right? So these are the three mechanisms of vascular spasm. So these are the three mechanisms. First, endothelin is secreted. Second, smooth muscle is directly hurt. And the third, the pain receptor activation. So endothelin, secretion of endothelin, smooth muscle or myogenic mechanism, and pain receptor activation. This is what this comes in vascular spasm, right? Now let us see the second step, the platelet plug formation. If you have missed out something in writing, you can write. Chalo, let us see the second step. What is the second step? The second step is platelet plug formation. It is a very interesting step, and see how our body is working so quick, right? Now let us see. Suppose these are these endothelial cells, and this is the injured site with the collagen and the smooth muscles, right? So now what will happen? What will happen is that these endothelial cells will secrete a protein. You can see the name, or you can just leave the name, it's not required. They will secrete a protein, and this protein is produced by endothelial cells. Now they are, since the endothelial cells are what? They are injured, right? So they cannot secrete heparin sulfate and PGI2. So the platelets will come and bind. What will happen? These platelets, this endothelial cell is secreting some protein, von Willebrand factor or VWF, you can say. And they are what doing? They, you can, for you, it's just a kind of protein. Endothelial cells are secreting some factor or a protein. And now, since the endothelial cells are damaged, they cannot secrete what? They cannot secrete the natural anticoagulant, or they cannot do the mechanisms of anticoagulation like secretion of heparin sulfate and all. So what will come now? The platelets will come and bind. So there is this specific protein on them, and to which the platelets come and bind. You will do this in MBBS in a lot of detail. So what will come? These are the platelets, right? These are the platelets, and this is what? This is some kind of protein which is secreted by endothelial cells. So now the platelets have come and just joined it, because there is this specific kind of protein on these factors on which these platelets come and join. So now when they will join, they will secrete three things. What will be those three things? Let us see. Now they will be secreting serotonin and thromboxane A2 and ADP. So these three things will be secreted when platelets join this protein. Now let us see what will happen. So what we learned since endothelial cells are injured, they cannot secrete heparin sulfate or prostacyclin Now what will happen? Now the platelets will come and bind to the protein secreted by endothelial cells, right? So this is the protein, and they just come and join over here like this, right? So the platelets come and join over here, nothing much to. And when it happens, what is secreted? Three things are secreted: serotonin, thromboxane A2 and ADP. Now let us see what will happen when these things are secreted, right? What will happen that, so basically we have done what? We have done the platelet adhesion step. So the platelet adhesion has taken place. Now some release reaction will take place. Platelet release reaction will take place. So this is the first step. Now this is the second step, platelet release reaction. What will happen? This ADP and thromboxane 2, right? This thromboxane A2 will bind to the platelets, and what will happen? Platelet aggregation will take place, right? Platelet aggregation takes place. Right. So if you just want to know some more thing, if these are two platelets, how are they combining? These are two platelets, and how are they combining? They are combining with there is some protein, and there is this fibrinogen, and they are combining together with fibrinogen, right? So now the platelet aggregation has taken place. So what happens to these three things? ADP and thromboxane A2 bind with the platelets, and platelet aggregation take place. Now we also call as TXA2 and serotonin. What will happen to the serotonin? Will also release. Now they love to bind with the smooth muscle, right? What will happen when they will bind to smooth muscle? Think. When they will bind to smooth muscle, it will cause contraction, and this will do what? This will enhance vasoconstriction, right? So जो तीनों चीज रिलीज हुई थी उसका हमने यूज भी देख लिया. तो प्लेटलेट प्लग फॉर्मेशन में क्या हुआ? प्लेटलेट प्लग फॉर्मेशन में एक प्रोटीन सिक्रेट हुआ एंडोथेलियल सेल्स के थ्रू, एंड द प्लेटलेट्स केम एंड binded themselves to that protein, and in that process ADP, serotonin and thromboxane A2 was released, right? And then what happened? Since endothelial cells are injured, they cannot secrete heparin sulfate or they cannot keep the blood naturally thin. So now the platelets will come and join to these to that protein that was secreted by endothelial cell. And in the process, three things were released: serotonin, thromboxane A2, and ADP. ADP and thromboxane bind with the platelets, and they do what? They do platelet aggregation, right? And thromboxane A2 and serotonin love to bind with smooth muscle, and they cause what? They cause vasoconstriction. So basically हमने क्या किया? हमने platelet plug formation को क्या किया? 3 steps में बांट दिया. We divided into 3 steps. What was that? That was platelet adhesion, platelet release reaction, and the third one was what? Platelet aggregation, right? So जब aggregate हुआ तो क्या हुआ? एक plug बन गया. So basically हमने ये तीनों steps कर लिए. Platelet adhesion, जिसमें वो आके प्रोटीन से जुड़ा. प्लेटलेट रिलीज में क्या हुआ? एक ADP, सेरोटोनिन और थ्रोम्बोक्सिन A2 निकले. और प्लेटलेट एग्रीगेशन में we saw how these three reacted and bound with the पूरा वहां पे उन्होंने एक एग्रीगेशन बना लिया. कैसे एग्रीगेशन बना लिया? Let us see in the diagram. ये है, तो ये पूरे यहाँ पे platelet. So basically what happened? There is a kind of a plug created to stop breathing, to stop bleeding, right? So ये उन्होंने क्या बना लिया? This is what? That is a platelet aggregation. चलो. So the second step we have done, that is the platelet plug formation. Now let us see the third step, that is coagulation. That's the very important step. And I'll tell you some trick in the end to remember this step. You can do it in 5 minutes if you want, but then 5 minutes में कितने marks आएंगे, you also know, right? So what will happen? Basically ये है endothelial cells, injured endothelial cells. Now we have drawn it many times. You all might be knowing. Then what I will draw? I will draw collagen. You also draw collagen. Then what will we draw? We will draw the smooth muscles, right? Now let us see what is happening. यहाँ पे क्या हो गया था? यहाँ पे था और इसके ऊपर platelet plug formation हो गया था, right? This is the platelet plug that has been formed to reduce the bleeding. We'll not go into much detail. You just need to know that it is negatively charged on the outside, right? This is what? This is platelet plug, and this is negatively charged on the outside. Now let us let us see what will happen in coagulation, right? Okay, so let us see what is happening in coagulation. There is this called factor 12, right? This is clotting factor. It interacts with the negative charges on platelets. ठीक है, इतनी बात समझ में आ गई कि factor 12 negative charges से react करता है. तो ये factor 12 inactive state में था. अब जब इसने negative charge से interact करा, what happens? This 12 becomes active, right? Now this 12 will react with inactive 11, and what will happen? This is inactive. It will also become active. So 12 के बाद 11. Factor 12 ने क्या किया? Negative charges और on platelet से react करा और active हो गया. और इसने क्या किया? जो 12th active हुआ, what did it do? It made the 11th factor active. So factor 11 भी एक्टिव हो गया। अब इसने क्या किया, इसने 9th फैक्टर से रिएक्ट करा और इसको फैक्टर 9 भी क्या हो गया, एक्टिव हो गया। ठीक है, अब क्या हुआ इसके बाद, फैक्टर 9 भी एक्टिव हो गया। अभी फैक्टर 8 and some calcium, they will come and along with the factor 10. So there is this factor 10 also in the blood. This is happening where? This is all happening in the blood. So जो 9 active हुआ था, it reacts with, or yeah, it reacts with factor 8 and calcium, and what happens? It factor 10 जो inactive state में था, it will become active. It is happening all where? What are these factors? If this is the bloodstream, these are factors are all present in the bloodstream itself. Okay, so these are all clotting factors we are talking about. Don't just forget. So right, abhi kya ho gaya, 10th bhi active ho gaya. What will this 10th do? It will activate something. It will react with factor 5 and some calcium, and it will activate prothrombin activator. You just see how things are moving. अब ये prothrombin activator भी activate हो गया. What will it do? Prothrombin जो एक inactive form में था, what will happen now? Activate prothrombin activator. So prothrombin, before thrombin, pro मतलब before, जो एक inactive form में था, उसको क्या किया, प्रोथ्रोम्बिन एक्टिवेटर ने एक्टिव कर दिया. एंड प्रोथ्रोम्बिन इन एक्टिव फॉर्म इज नोन एज व्हाट? इट इज नोन एज थ्रोम्बिन. एंड थ्रोम्बिन हमने पढ़ा था कौन सा फैक्टर होता है? इट इज फैक्टर 2, राइट? अब ये एक्टिव हो गया, राइट? अब क्या होगा, दिस थ्रोम्बिन आल्सो कॉल्ड फैक्टर 2, it will link the fibrinogen. So जैसे ये फाइब्रिनोजन है, ठीक है, these are what? These are fibrinogen. और ये क्या होते हैं? ये soluble होते हैं, ब्लड में soluble होते हैं, राइट? बट जब फैक्टर 2 या थ्रोम्बिन आएगा तो क्या हो जाएगा? it will make it insoluble. Basically it will convert it into fibrin. So fibrinogen will convert it into fibrin, right? और फाइब्रिन कैसा होता है? जैसे ये है तो ये they will all come close. So basically what happens, they all get accumulated and this fibrin is what? This is insoluble, right? So basically what is happening when it is insoluble, what is happening? The blood is becoming into a more gel-like substance. शुरू हो गया coagulation. As you can see, coagulation has started. Now what will happen? But ये तो ऐसा है, बट हमने बहुत बचपन में पढ़ा है कि वो mesh like होता है and also what is that? तो जो thrombin है और जो factor 2 है, that factor 2 that is also known as thrombin, what will it do? It will interact with fibrin stabilizing factors. It will interact with fibrin stabilizing factors. Fibrin stabilizing factors को हम factor 13 भी कहते हैं. And what will happen then? And will cause cross-linking of fibrin, right? Cross-linking of fibrin. तो let us see क्या हो गया. ये fibrin, ये platelet plug है. Suppose this is the platelet plug. अभी इसने fibrin ने it becomes cross-linked, and what happens? It becomes a fibrin mesh. Right? So here what happens? Let us see what happens. यहाँ पे ये पूरा fibrin mesh बन जाता है, and the blood coagulation begins, and the blood becomes gel-like. Right? So we saw all the factors that are helping in the blood. And what are these factors? These are the clotting factors. What are these factors? These are the clotting factors. Remember, no, don't forget what are these factors that we are talking about, clotting factors. So the first step is that the factor 12 that interacts with the negative charges on the platelets, and that becomes active. So the first step, the factor 12 becomes active. Then it makes the 11th from inactive to the active state. Then 9, and then they react with factor 8 and calcium, and then 10th become active, and they react with 5th and calcium. I will give you a very easy trick to remember it, so don't worry. It activates the prothrombin activator, and then it activates the thrombin from the prothrombin, and this thrombin will convert fibrinogen to fibrin, which is insoluble, and this fibrin will what? This will become gel-like substance. And what will happen with this fibrin? This thrombin will also react with factor 13th or fibrin stabilizing factor, and this will form what? This will form fibrin mesh or cross-linking. So this is all about coagulation of blood. Now let us see the step 4. You can once see it again and see if you have missed out anything in coagulation. Right? So we have done this. Now I was telling you about some way. So basically what you can see is 12, say 11, then 9, then 8, and then factor 10th. And 3, 7, and then 10. So what I am drawing this, these are two pathways. That's the extrinsic pathway of coagulation, that is fast, and that's the intrinsic pathway, that involves a lot of steps, right? Extrinsic and intrinsic pathway. Factor 10th is also known as, for your information, very common word in the book, thrombokinase, right? And then there is factor 5, 2, and 1. Factor 2 is very important, thrombin, and factor 1 is what? Fibrinogen. So this is a way, 12, 11, 9, 8, 10. And as you can see, 12, 11, 9, and 10th, right? And 5 and 2. So this is where you can just remember it. So extrinsic and intrinsic pathway you can remember. 7 plus 3 is 10, and 5 into 2 into 1 is also 10. So you can remember this intrinsic and extrinsic pathway very easily. This is just a trick. 12, 11, 9, 8. 3, 7 is 3 plus 7 is 10, and 5 into 2 is 10. So very easy. And these are what? These numbers are what that I have written. These are the clotting factors. So this is just a way to remember, right? With this you will never forget. 12, 11, 9, 8, 3, 7, 5, 2, right? Chalo. Let us see the next step. What is the next step? The fourth step is clot retraction. What is this clot retraction? Clot retraction is basically consolidation or tightening of fibrin clot, right? Of fibrin clot. And what happens? Platelet retraction happens. So endothelial cells come close by. What have I written? You just read once. consolidation or tightening of fibrin clot and platelet retraction also take place. So the endothelial cells come close together. So basically what happens once a clot is formed, it plugs the ruptured area and this stops the blood loss. Now what has happened, this or tightening of the fibrin clot is clot retraction. Basically जब यहाँ पे clot बन गया, endothelial cells है, यहाँ पे clot बन गया, this is what? This is the ruptured area and this is the clot. So basically what is happening in fibrin retraction, it is just the tightening of the fibrin clot. So you can just remember the tightening of fibrin clot is clot retraction, right? Nothing, it is important, but no steps to remember. Now let us see the fifth step, that is fibrinolysis. From the name only you can see fibrinolysis. So there is something called it is dissolving something, right? So there is this protein in the blood. There is this protein in the blood, plasminogen. What is plasminogen? It is protein in the blood. And what is this plasminogen doing? It reacts with the tissue plasminogen activator. And what happens? It becomes plasmin. And what does plasmin do? Plasmin loves to eat fibrin. And what happens? And fibrin is what? It is an active plasma enzyme, right? Or you can just see it loves to eat fibrin. No need to know this, right? So basically what is happening when a clot is formed, an inactive plasma enzyme called plasminogen is incorporated into the clot. So that is basically what that is just is reacting is with the tissue plasminogen activator, and a plasmin is getting formed and it loves to eat fibrin. So what is happening? The fibrinolysis, it is basically what? It is a fibrinolytic system. What is doing what? It is dissolving small inappropriate clots at the site of damage once the damaged site is repaired. So what is it actually doing? It is dissolving small clots or inappropriate clots at the site, at the injured site or at the injured place. उससे क्या होगा? Once the damage is repaired. Once the damage is repaired. So basically चोट ठीक होने के बाद बस ये फाइब्रिनोलिसिस होती है. फाइब्रिन को खत्म करने के लिए प्लाज्मिन बनता है. प्लाज्मिनोजन से प्लाज्मिन बनता है और वो फाइब्रिन को खा लेता है. और कब? When the damage is repaired. So एक बार हम इसको लिख लेते हैं लास्ट स्टेप को. फाइब्रिनोलिसिस में क्या हो रहा है एक बार रिवाइज कर लेते हैं. प्लाज्मिनोजन से इट इज अ जाइमोजन, इनएक्टिव स्टेट, प्लाज्मिन बना. प्लाज्मिन ने क्या किया? फाइब्रिन को लाइसिस कर दिया, खा लिया. और बेसिकली यू कैन मेक दिस एंड इट एट अप फाइब्रिन and this is what is fibrinolysis, right? So this is what was in today's class. So we did a lot today, and it was a very nice class. We did all the steps, and we did, let us see from the beginning, or it's a very big class. So we did many things today, and you have to take notes also, and you have to take a copy and sit with me whenever you are doing. So we did coagulation of blood. So the first thing we did was how the blood is kept naturally thin, and finally we did, so you have to remember all these things. They are very easy once you read many times. And then we did the 5 steps of hemostasis: vascular spasm, platelet plug formation, in which there were 3 steps, coagulation, clot retraction, and fibrinolysis. So guys, today's class is over. Please take notes. This is a very important topic in blood fluids and circulation. Stay home, stay safe. Bye.